In our previous session, we had a detailed discussion about average speed, its concepts, various cases and everything. And in this session, we are going to discuss about how we are going to approach any question that is based on the concepts of trains. Whenever we see some train questions, the problems will be like a train is crossing a signal post, a train is crossing another train, or a train is crossing a tunnel. Then what would be the length of the train, or what will be the time taken for the train to cross the tunnel? Like these, we'll be having some sample questions. So totally we can just take all these kind of questions under 4 different cases. Now let us discuss all these 4 different cases one by one. Out of the total 4 cases, in the first 2 cases we are going to see what happens when a train is going to cross any stationary object. A stationary object is which is going to remain in the same place, it is not going to move. Okay, so we'll come to the first case. Case 1 is a train crossing a tree, a signal post, or a stationary man. Okay, so if you see these kind of objects, a tree or a signal post, what happens is it will be a single point object. It will be in a single point and it is not going to move anywhere. Okay, it is going to be fixed and we don't have any particular length for that particular object. Okay, and same for a stationary man also. Stationary man is a man who is going to stand in some place. Okay, so let us now see what happens when a train is going to cross these kind of objects. Okay, so for example, let us take that this duster is going to be the train and we'll assume this marker to be the tree. Okay, so let us see what happens. Now this train is going to cross this tree from this side and it is going to do the opposite other side. Okay, let us see what happens and we will clearly see when this process is going to start and when it is going to end. Okay, so we can say that when the train's front end, when it going to coincide with the tree, this time only the process is going to start. Okay, now the train, whole body of the train should be crossing the tree and its back end should completely cross the tree. Only when we can say that this process is over. So let us carefully see now, in order to complete this process, how long the train needs to travel, how much distance. If we see that clearly, the train needs to travel its own length as the distance. Okay, so is that clear what we have seen now? So when a train is going to cross these kind of objects, tree, signal post, the train need to cover a distance of just its own length. So distance will be equal to length of the train itself. And next let us come to the speed part. Okay, here if we see the moving object, the only moving object is the train. Okay, and the other objects, the objects which the train is going to cross, they are not going to move, they are all stationary. So to consider the speed we have to consider only the speed of the train. That's it. So I hope you are able to understand this concept. So now we are clear about what is the distance and speed. If we need time, what we can do, just we can divide distance by speed. Okay, so when we divide distance by speed, we will obviously get what is the time, but there we should be a little careful because we should be checking the units of the distance and speed. Okay, if distance is in kilometer, then if we have the speed in kilometer per hour, it will be better, because when we divide them, we will be getting the answer of time in terms of hours. Similarly, when you have distance in meters, we should have speed in terms of meter per second. Then if we divide, we can get the time in terms of seconds. Okay, so this is how we'll have to calculate when we have this kind of case. Next, coming to case 2, train crossing a platform, a tunnel, or another stationary train. Unlike objects like what we had in case 1, we have some particular length for objects like a platform or a tunnel, whatever. Okay, suppose if we have a platform, then we definitely have some length for this particular platform, right? So that length can be whatever, it can be 100 meter or 200 meter, whatever, but it will have some length. Okay, let us now see what happens when a train is going to cross these kind of objects. Okay, again we will assume that let this duster be the train and we will assume this marker to be the platform. Okay, let us see what happens when this train is going to cross this platform. We'll take that this train is going to cross this platform here and goes to this opposite side. Okay, now we will clearly see again when this process will start and when it is going to end. Okay, so when this train is going to approach here, we can tell that the process is going to start only when the train's front end is going to coincide with the back end of this platform. Okay, so here only the process is going to exactly start, and now the train is going to travel like this, And again, we can't say that the process is over here, because now the train's whole body is over the platform only. Okay, again the train has to move this much distance, and we can tell the process is going to complete only when the train's back end is completely going to cross the front end of the platform. So this is going to be the overall possibility. Okay, that is, so now when the train is going to cross this platform, we will see the entire distance, how much it is going to travel. Okay, so if it is going to cross it, the train needs to travel a length of the platform first, then once again the train needs to travel its own length. Okay, so when you want to find the distance is going to be nothing but the addition of both the lengths. Okay, this is what we have to do here. So distance traveled by the train when it's going to cross these kind of objects, distance will be length of the train, then plus the length of whichever object it is going to cross. Length of whatever it is, it can be a platform or it can be a tunnel, whatever. Okay, so here we have to take the distance to be the sum of both the lengths. Okay, and now coming to the speed is more similar to the first case, because here also the train is going to cross some stationary object only. So what we have to do here, the only moving object is the train. So again speed is equal to the speed of the train only. So in case 2, this is how we'll have to take the distance and speed. Once again, it will help us to find what is the time taken. Now in the next 2 cases, we will see what happens when a train is going to cross a moving object. Okay, so case 3, a train crossing a cyclist, a runner or a man in another moving train. We will see what happens when a train is going to cross these kind of objects. If we see, this is very similar to our first case. So here these objects, if we see, they don't have any particular length, they are all single point objects. So what we can do, if you want to find the distance covered, then we have to consider only the length of the train. Okay, so distance is equal to length of the train. And next, coming to the speed is very much important here. If you see here, both the objects are moving, the train as well as the cyclist, both of them are moving. So when 2 objects are moving, we will have to consider the relative speed. So in relative speed, what we usually do, we have already clearly seen about what is relative speed. So in relative speed, what we need to do is, we have to see in which directions both the objects are moving. So if the 2 objects are moving in the same direction, then what we have to do? Same direction, we'll have to just find the difference between the 2 speeds. Okay, same directions, we have to take the difference between, that is, we have to subtract. And if the objects are moving in the opposite direction, that is, if the cyclist and the train, they both are moving in opposite direction, that time we have to take the sum, addition of the 2 speeds. This is how we'll have to take the speed. So this is how we find the relative speed. And finally, we'll be finding the time just by dividing the distance and speed, as we did it earlier. And next, come to the last case, 4th case, a train crossing another moving train. So again here, what about the distance? Here distance will be, because we have 2 trains, okay, 2 trains, in the sense we have the lengths for both the objects, then what we need to do is, we'll have to take the addition of both the trains' length. So distance will be equal to length of the first train, train 1, plus length of the other train which is going to be crossed, train 2. So train 2. So this is what will give us the distance covered. And next, coming to the speed again similar to our 3rd case. Here both the objects are moving, so we will have to consider the relative speed of the object. So we will have to take relative speed as the speed, very similar to the previous one. If it is relative speed, means when it is same direction we have to find the difference, opposite direction we have to add the 2 speeds. Again, if you want the time, we can just divide distance by speed to get the time taken. Friends, I believe that now you are able to get some idea about how to solve train problems. But now we have just seen the concepts alone. I will soon upload you some solved problem videos about trains in my other channel, VAAGAI Math for You. Kindly see those videos also, because if you see that, you will get more ideas about how to solve problems. So for more maths concepts like this, shortcuts, kindly subscribe to my channel, VAAGAI Math Coaching. And let us catch up in the next session with a new concept. See you there. Thank you so much.